15 sounds bad. All right, so what we want to do is we want to go through, we want to set up our equations. It says find two numbers such that the sum of their reciprocals is 4, and 4 times the product of their reciprocals is 15. So right here, all I know is it's saying find two different numbers. When they're asking for two different numbers, I'm going to use two different variables. So I'm going to let x equal the first number, and y will equal the second number. So then it says find two numbers such that the sum of their reciprocals. Well, if x is the first number, how would I represent the reciprocal of x? 1 over x. And if y is the second number, the reciprocal would be 1 over y. So it's saying find two numbers such that the sum of their reciprocals is 4. This is my first equation. So I'm going to have 1 over x plus 1 over y is equal to 4. But since there's two unknown variables, how many different equations do I need? 2. So we have one equation. Now we need another equation. The next equation is saying 4 times the product of their reciprocals is 15.
Can I leave a water bottle in here?
You can look around. Do you guys, anybody see a water bottle anywhere?
It's probably like under that desk in the corner.
Oh yeah, there it is.
Okay.
Glad you found it. Okay, so now it's saying 4 times the product of their reciprocals is 15. So we're going to do 4 times, product means multiplication. So I'm going to multiply 1 over x times 1 over y is equal to 15. So for my second equation, I'm going to combine this, and I'm going to get 4 over xy equals 15. So right now, I need to solve. I finally have my two different equations. Now I need to solve. Our two options for solving a system of equations is through elimination or substitution. I will tell you elimination is not the choice here. The reason elimination is not the choice here is because normally in elimination, we stack up the ones that look the same. These are not represented in the same way. This is 1 over x, this is 1 over y, this is 4 over xy. It's not the same. It's not going to be easy to cancel something out. We're not going to like that. So with that said, I'm going to use substitution. To use substitution, I want to solve for one of the variables. So I'm going to go to the second equation, 4 over xy equals 15. Now I'm going to solve for either x or y, but I can't solve for something that's in the denominator. So what I'm going to do first is cross multiply this, and I'm going to get 15 xy equals 4. Now let's say I want to solve for x. If I want to solve for x, I need to get isolated. I need to get it all by itself. Aren't both the 15 and the y multiplying to the x? So to undo multiplication, we're going to divide. So I'm going to divide by 15y on both sides. So here I'm going to have x is equal to 4 over 15y. So now that I solved for one of the variables, what I'm going to do is I'm going to go back into the equation that I didn't manipulate. I manipulated the second equation, so now I'm going to go back to the first equation. So the first equation was 1 over x plus 1 over y equals 4. And now wherever I see an x, I'm going to put in 4 over 15y. So this is going to be 1 over 4 over 15y plus 1 over y equals 4. Now I want to simplify this. 1 over 4 over 15y. Isn't that the same as saying 1 divided by 4 over 15y? keep, change, what? Flip. So this is the same as 1 times 15y over 4. So now we're going to have 15y over 4 plus 1 over y equals 4. I'm going to bring this up here. Okay, so now I want to solve this equation. I don't want to deal with the fractions. So what I want to do, since it is an equation, I'm allowed to do this. I'm going to eliminate the denominator. How do I eliminate the denominator?
Multiply everything by 4y.
Excellent. We're going to multiply everything by 4y. So here the 4's cancel, then the y's cancel. So I'm going to end up with 15y squared plus 4y, plus 4 is equal to 16y. Do we all agree this looks like something that's going to be factored? So I need to set it equal to 0. So we are 15y squared minus 16y plus 4 equals 0. If we factor this, we're going to get a 3y minus 2 and a 5y minus 2. And then we solve and we get y equals 2/3 or y equals 2/5. All right, now that I have the y values, now what I'm going to do is plug in to find x. And if you guys remember, x was equal to, what was it equal to? 4 over 15y. So I'm going to plug in the 2/3 first. 4 over 15 times 2/3. In that denominator, I'm going to simplify. I could cross simplify. 3 goes into 3 once. 3 goes into 15 5 times. So I end up with x is equal to 4 over 10. So x will equal 2/5. And then the other one is going to be, again, x is equal to 4 over 15y. So x is equal to 4 over 15 times 2/5. And again, we can cross simplify. 5 goes into 5 once, 5 goes into 15 3 times. So we get x is equal to 4 over 6. So x will equal 2/3. So what are our solutions? Our solutions will be the combination of 2/5 comma 2/3 or 2/3 comma 2/5. So if x is 2/5, then y has to be 2/3. And if x is 2/3, then y has to be 2/5. Or we could look at it, one number will be 2/5 and the other number will be 2/3. All right, so that's the first problem. I guess I didn't leave much room. Are we ready for the second problem? Yes.
If we're solving for two numbers and we get two answers for y, can we assume that those are the two numbers?
No, you have to plug back in because sometimes one of those numbers won't work out. It will like yield an imaginary number, so we'd have to reject it. So you'll actually see something like that in the next problem. All right, next problem. So it says find a fraction such that psi, what are you doing, psi?
Isn't that my emails?
No. Guys, Sai was off track. He wasn't doing what he was supposed to do. Usually that's Kartik.
Whatever. But like, run.
No defense.
Whatever.
Sai, this is like shocking. This is like when Damien was mean to me. Yeah.
Sai, that is crazy.
That one time percent.
He was checking his email.
And like he's sitting right in front of me, and then he's like poking Caden to look at his screen.
Listen,
You're not even sneaky about it. At least Kartik's sneaky about it. He switches his screen real quick.
I don't switch my screen.
It was about our chem test on Thursday.
Aw, that was funny.
No,
The emails are like a lot.
Okay. I'm just messing. I don't really care.
The corruption is spreading in this day.
The what? The corruption is spreading. I know. This year needs to be over. All right. So it says find... Okay. Find a fraction such that the difference of the squares of the denominator and the numerator is 189, and the square of the numerator is 6 more than twice the denominator. I know this is a mouthful, but going through this, there's two things being compared, the numerator and the denominator. So I'm going to go ahead and I'm going to let n...
Stop poking me, I'm trying to do my work, bro. Caden Mago is distracting me.
So n is the numerator. We're going to let d equal the denominator. And now we have to translate this into an equation. So it says find a fraction, so numerator over denominator, that's our fraction, right? Such that the difference of the squares of the denominator and the numerator. So not only are we taking the difference, which means subtracting, before we subtract, what do we have to do to them? Square them. And because denominator is written first, the d is going first. So I have to use d squared minus n squared is 189. That's my first equation. All right, the second equation.
The square of the numerator is 6 more than twice the denominator, so it's n squared is equal to 2d plus 6.
You got it. The square of the numerator, so the numerator squared, n squared, is, which means equals 6 more than twice the denominator. So we're going to say 2d plus 6.
You're welcome, Sylvia.
Okay, so now we have a choice here. We can either solve through elimination or substitution. The reason this time we can solve through elimination is because at least we have one variable that's exactly the same, an n squared and an n squared. For that reason, we can solve through elimination. So would you rather solve this through elimination or substitution? Elimination? Okay. So to solve for elimination, what we want to do is line them up and make sure they're in the same order. So I have d squared minus n squared equals 189. So all variables on one side, anything without a variable on the other side. So then for the second equation, I need to manipulate just a little bit. Do we all agree I have to subtract the 2d? So I'm going to subtract that 2d over. So minus 2d plus n squared equals 6. Uh-oh. I need the plug. 1 second.
No, it's just like a regular.
All right. Oops.
Did you say multiplies for 1 more than 5? It's 1 over 9.
Okay. So now when we add these together, and I can add them because I have a negative n squared and a positive n squared, so that's exactly what we want to do. We're going to have a d squared minus 2d. I can't combine those because they're not like terms. One is a squared, one is not. The n squareds cancel, which is exactly what we want, equals 195. Do we all agree this looks like we need to factor?
It does.
Yes. So I need to set it equal to 0. So we're d squared minus 2d minus 195 equals 0. Yes, Kartik?
It would be d plus 13 times d minus 15.
Perfect. So we end up with d equals negative 13 and d equals a positive 15. He is good.
Shut up, peanut gallery.
What? You're weird.
Joey's just cranky all the time.
Spanish. He
See,
was
at
crashing
least I'm,
out in
like,
Spanish because he couldn't get
happily
his
complain.
thing open.
Yeah.
I happily complain. I'm like, oh, let's have an off day. It's all fun. Sick of school.
Yeah, Joey's just angry.
I don't want to be here anymore.
Joey, I take that very personally. I
It's
love
birthday. You
spending.
shall say
Is today your birthday?
Alright, hug.
We should have had a class party for you, Joey. Maybe that would have made you happy.
His birthday got ruined by the Spanish test.
Hey, what do you got in Spanish? Dude?
No, he was just crashing out.
You always can complete the square instead of factoring. It just might take a little bit longer, but yeah, it works.
It won't get graded.
Did you add whatever you added to the left side onto the right side too? I'll look at it. Let me just finish this problem with them, but something might have just gone wrong. So, guys, let's keep going. So now that we have d equals negative 13, d equals 15, now we're going to sub back in for n. If you remember, we wrote that n squared is equal to 2d plus 6. Guys, enough side talk.
Teach me something very important.
Sai wasn't talking. So we're doing negative 13 first. 2 times the negative 13 plus 6. We're going to have n squared is equal to negative 20. Is that possible? No, because if I square root a negative number, isn't that imaginary? So for that reason, I am rejecting the negative 13. So now let's go and sub in the 15. So n squared is equal to 2d plus 6. So n squared is equal to 2 times 15 plus 6. N squared is equal to 36. So n is equal to? Good, plus minus 6. So now I have the d, and I have the n, and I'm going to go back and see what we were asked for. Find a fraction. Okay, so what is the fraction we're dealing with? The fraction is going to be the numerator, which is plus minus 6 over the denominator. And what can we do with that fraction? Simplify it. You can. 2/5, you're right. I wrote it wrong.
Wait, so why was it not
Divided by 3.
Whenever Karthik knows an answer, he like says it. Like gotta respect him for it.
The 13 gave us a negative number, and you can't square root a negative number because it's imaginary.
No, he's him for that.
Right here, when we plugged in negative 13, see where it says n squared equals negative 20? At that point, we'd have to square root it.
I see. I think they rejected that sucks. Yeah. I think if you ask someone around, they're like, yeah. What?
I wouldn't know.
Yeah, no, I said it's up to reject. Yeah.
All right, let's keep going.
That's just messed up. No, it is. You're like, I want to be a part of it, and they try to square me. No, you can't be squared. That's a negative. You're just yapping.
Next period.
But he's yapping happily.
It's disrupting.
It still makes me feel happier than your broody ways.
Be nice to him on his birthday. We'll make fun of him tomorrow.
Aw.
Oh. See?
Wait, why are those the two fractions?
He's taking away.
Because
from
it's just one fraction, or plus minus 2 over 5.
I have a high.
I simplified it.
I would give you mine.
I wonder how many times.
Joey, how old are you? 16. Are you getting your permit?
Yeah.
You have to do your 6 hours?
Yeah.
Did you pass the written test already?
Yeah.
Oh, she's recording.
Good talk.
This lesson? Oh.
Oh shoot.
Oh my gosh, my.
Oh, yo, how many Vine Booms has that recorded?
Like a lot, bro.
All right, we're almost there, guys. 3 more problems, then we're done. 3 more, then we're done. This one's probably the worst one. Or maybe the next one's the worst one. I don't know. All right. An art dealer bought some paintings for $360. When a storm ruined 2 of them, he sold the rest for $380, thus making a profit of $8 on the original cost of each picture. How many pictures did he, it should be paintings, but it doesn't matter, you guys get the gist, pictures equals paintings, did he buy? All right, so 2 things we're talking about. We're talking about the actual number of paintings, and what else are we talking about? Damien? The cost, exactly, the cost of the painting. So I'm going to let n equal the number of paintings I'm going to let the C equal the cost per painting.
I only use X and Y.
That's fine.
It's much better.
Well, these like represent what they mean, like n number, C cost.
I used to do the same thing as you, Matt. Then like I kind of got lazy and I feel like going back and looking through.
I don't know. It's just like I only use X and Y.
It's okay, you're allowed. All right, so it says an art dealer bought some paintings for $360. So if I bought 5 paintings and each painting was $10, how would you find how much I spent? Wouldn't you do 10 times 5? Right? But do I know the number of paintings or the cost per painting? I just know the number of paintings times the cost per painting equals 360. So that's our first equation. So where first equation is going to be n number of paintings times the cost per painting is equal to $360.
If we were to graph that, it would be a hyperbola.
Yeah. Okay, so now the next equation is a little bit more complicated. It's saying when a storm ruined 2 of them, 2 of what?
Paintings.
The paintings. So what happened? I had n amount of paintings, n minus 2, but now we lost 2. So now we're dealing with n minus 2 number of paintings. He sold the rest for $380, thus making a profit of $8 on the original cost of each painting. How many paintings did he buy?
Wait, how do we know each painting's the same amount?
Where it's just inferred by reading it. He didn't say, if they said paintings cost different amounts, then we would have to. But if they're not saying that, it's inferred that it's the same amount for each painting. Yes.
We don't know that.
Since we know that there's a profit of $8 on each painting, profit of C, it means that we're gonna have to multiply n minus 2 times C plus 8 into G.
You got it. He is.
I mean, I already did this stuff earlier. My mom made me practice this over spring break.
Mom, what? What did you
My mom made me practice this over
This
spring
wasn't
break.
posted over spring break.
No, she did. She posted the syllabus, and my mom's like, good enough, do these.
Good. Okay.
Like, I basically have
So let's show you, since Kartik did this already, let's show you where he got this next equation from. So what happened was we lost 2 paintings, so that was the n minus 2. And then to sort of make up for that loss, those 2 lost paintings, they increased the price per painting by $8. So now when they sold all the paintings, they made a total of $380. So that's why it's n minus 2 times the quantity of C plus 8. Okay, so what happened? We lost 2 paintings, right? So that's n minus 2. Now, the seller, to make up for those lost paintings, he increased the price of each painting by $8, so C plus 8. So with the 2 paintings gone, n minus 2 times the new increased price, that total was $380. Okay, so now I'm going to FOIL out the second equation to see what we have here. So when we FOIL out, we get NC, right, in pink, plus 8N minus 2C equals 380. Would elimination be a good idea here? No. Elimination is not an option here. What we want to do is use elimination. And look here, NC equals 360. Well, isn't there an NC right here? So I'm going to take that 360 and sub it in for NC. So now I have 360 plus 8N minus 2C equals 380. What's wrong?
Before you continue, you forgot the -16 on the floor.
So it equals 396.
Oh, thank you. I knew something went wrong when all those hands went up. It's a minus 16.
You got yours.
I appreciate you. And I can make that I could bring that 16 to the other side to make it 396. Now we good? Good. Okay, so now I subbed in that 360. What should I do with that 360? Subtract it, right? I just want to try to make our number smaller. So now I'm going to subtract the 360 on both sides. And now I'll have 8N minus 2C is equal to 36. Is there anything else I can do here to make these numbers smaller? I could divide by a 2, exactly. So then I'm going to have, if I divide 2 under everything, pull out a GCF of 2 and divide.
Wait, how did the 360 come in the second equation? Because she subbed it in because
4N minus C equals 18. Okay. This is as far as I can simplify, right? I still can't solve this because I'm still dealing with 2 variables. So I have to go back. I have to go back to the other equation, the NC equals 360, and now I need to solve for one of the variables. So if I have NC equals 360, let's solve for
C.
C, sure. If I solve for C, what do? Divide by? So C will equal 360 over N. All right, I'm going to bring this all the way up here now. So now we have 4N minus C equals 18, and I'm going to sub in the 360 over N for C. So we have 4N minus 360 over N equals, oops, not 180, 18. I want to solve this, but I don't want to deal with fractions, so I'm going to eliminate the denominator. How do I eliminate this denominator? Multiply by n. So when we multiply by n, I get a 4n squared minus 360n, minus 360 equals 18n. Bring that 18 over.
And you can divide them by 2.
Yeah. Kardic's right. We can now simplify this a little bit by pulling out a GCF of 2. So we'll have a 2n minus 9n minus 180. And now we factor. Oop, 2n squared. I lost my squared there. So we're going to have a 2n plus 15 and then an n minus 12 equals 0. And then we solve. 2 can't equal 0, so that's out. We're going to get an n equals negative 15 over 2, and n will equal 12. What does n represent?
Number of
Paintings. Could I have a negative 15 over 2 number of paintings? No. So what's going to happen with that negative 15 over 2? We're going to reject it. Don't be sad, Matt. They'll find somebody else.
What? Oh. That's kind of a negative number.
'Cause 2 negatives make a positive.
It'll be like.
It will work.
We should like. It should be like negative 15 over 2 and negative 2 over 15. I'd like it.
Perfect match.
Perfect match.
There you go. All right, so n equals 12. Now go back. Do I even need to sub back in? No, because what was it asking us? How many paintings did we sell? Or how many paintings did he buy? How many paintings? 12 paintings. So our solution here is 12 paintings. We don't even need to sub back in. This one was pretty ugly. The next one's a little ugly. The third one's not bad. Or the last one's not bad.
Wait, isn't this the third one?
I mean the, like, last one. Yes, the 5th one.
I know.
Tom.
Kidding this one.
I don't know. I don't trust
I
Tom.
don't mess with these word problems.
I think they're very fun, guys.
I think we should.
Just 'cause your mom-
This unit was so good up until this lesson, right?
Honestly, I feel like graphing was harder than the word problem.
No, I like.
How many word problems
Dude,
do you
graphing
have?
is just.
I don't know. I'll give you the breakdown next class, I promise.
One problem is just understanding the.
Is it like
I'll
more than
consider
two?
it.
It's just reading, bro.
I have
If
to
you
look.
wait, then you'll find the
Next
problem.
class is Thursday.
Yeah.
Then test is Friday.
Yes, correct.
It's actually gonna
Listen,
be
Can I
Graph-
trade 3 graphing problems for 1 word problem?
Yes, I would love that.
Tom wants to make a window from a window box from a rectangular sheet, galvanized metal whose area is 680 square inches. He cut 6-inch squares from each corner and folds the sides to make a box whose base area measures 176 square inches. Find the dimensions of the original metal sheet. So, Joey, what's happening is
Chill.
I'm not saying anything. I'm saying, Joey, can I incorporate you into this problem-solving strategy?
Oh.
We
You
should
just,
make
like,
it.
intersperse
Make the
people's
person
names
named
into
Joey
problems.
instead.
I really should.
No, on the test,
Tom
you
is
should
Joey.
like put people's names in it.
Noah and
Yo, you
So,
should, like,
my
Mr.
son,
Cookie.
my oldest son, his first grade teacher, it was her first year teaching. So every worksheet he brought home for math had the kids in the class's names in them.
Oh, my sister
So,
did
yeah, so she'd incorporate all the kids in the class. Fast forward now 3 years, my younger son also now gets this teacher, and she's sending home the worksheets for homework, and it's still the first year's, like, Zeki's kids' names in them. She never changed them after the first year.
You should put our
So-
names in it. No, remember when
Would
you
I
said the
change
Cardi
it and put your
Cardi
names
teacher
in?
test?
Yeah, I remember.
I'll think about it.
Yeah.
Put Cardi's name.
All right.
Yeah,
So Tom wants to make a window from a rectangular sheet. So what am I drawing? A rectangle.
Tom is somebody.
Tom's a goat, bro.
I think I can find Tom and link somewhere. Give me a second.
But why are they using galvanized metal?
Why are we
I
so
feel like
galvanized
that's so
square
excessive.
steel?
I don't even know what galvanized metal is. I'm not going to lie.
He's really strong.
So right now,
Will Johnny expand? I'm gonna show you how easy galvanized is to follow.
Wait, hold on. With eco-friendly wood,
Yeah, he
too.
borrows the screws from his aunt.
guys, we're never going to finish. So now it says whose area is 680 square inches. What shape are we dealing with? A rectangle. How do we find the area of a rectangle? Like times width. I do not know the length and I do not know the width, and it does not matter which side you call length and which side you call width. It does not matter. So I know my first equation is going to be length times width is equal to 680. So now what's happening is Tom is now going to cut 6-inch squares from each corner. And what do we know about all the sides of a square? They're all the same. Okay, so now what's happening is we're cutting out 4 of these squares. And now he's going to fold this up and make this into a box, but we don't really care that he's folding this up and making it into the box because he's not saying the area of the new box. What is he saying? He's saying to make a box whose base area now measures 176 inches. So he's not saying the area of this new box, right? They're saying just the base. Well, the base was the original rectangle, but haven't I cut out? Yes, I've cut out 12 inches from the length, but I've also cut out 12 inches from the width. So now the area of this new base, L minus 12 times W minus 12, you got it, equals the new area, which is 176. All right, I'm going to FOIL the second equation. So we're LW minus 12L minus 12W plus 144 equals 176. What do you think I'm going to tell you to do with that 144? Subtract it. So we're going to have LW minus 12L minus 12W equals 32. Anybody see anything else I can do right now?
No?
Yeah, go back to this first one. It says LW equals 680. Well, isn't there an LW right here? So I'm going to sub in that 680. So we're going to now have 680 minus 12L minus 12W equals 332. What do you think I'm going to do now?
You're going to subtract 680 from both sides.
Yep, we'll subtract 680 from both sides. And what do we get? I don't know. I'm going to trust you. What'd you say? Negative 648? Okay. Anything else I can do to make this simpler? I could divide by negative 12 on both sides. Under everything, negative 12. Everything's divisible by a negative 12. So now, let's bring this over here. I'm going to have a positive L plus a positive W equals, what is it? I don't know. 54? I like that. That sounds about right.
Shouldn't it be times?
It's not the bar. Wait, I have a very important question.
600 is about 50.
No, we've been manipulating this whole thing. It was originally times and then we foiled it all out and been manipulating it ever since. Card it.
12 times y minus 12 is the area of like the white section that isn't cut out.
Crazy pull.
It's the white section that wasn't cut out, right? That's the area.
LW is the area, the white section that's not cut. L minus 12 times W minus 12, yes.
That's the area.
Yes.
But like, shouldn't it be 680 minus 176 then? Because like, you're subtracting the area of those pink squares from the total.
No, they're saying, no, I'm not subtracting the area. They're saying this is the 176 is the area.
Okay.
After they figured it out. So now let's keep going. So now we have L plus W equals 54. Is this good enough? No. So what do I have to do? I have to go back to my first equation and solve for one of them. Does it matter which one? No. Which one do you want to solve for? Sure. LW equals 680. So L will equal 680 over W. So now I'm going to sub in 680 over W plus W equals 54. Very similar to the process we just did before in the other problem, right? I'm going to eliminate the denominator. So I'm going to have 680 plus W squared equals 54W. If we factor, we're going to get a W minus 34 and a W minus 20. So we're going to get W equals 34 or W equals 20. And if you guys remember, L plus W equals 54. So what does that tell us? If the width is 34, then the length is 20. And if the width is 20, then the length is 34. So the dimensions will be 20 by 34, and it doesn't matter which way you're really looking at it. One's the length, one's the width. If you wrote 34 by 20, it's equally correct. All right, last problem. We ready? This one's not bad. It's not bad. This was the worst of it. The two problems we just did was the worst of it. I love triangles. Okay. The legs of a right triangle are represented by A and A plus B, respectively. The hypotenuse measures 15 feet. If the smaller leg is increased by 7 feet and the other leg remains unchanged, the hypotenuse is increased by 5 feet. Find the length of each leg. Joey?
She just said the name incorporated in the problem.
So what I want to do is I want to draw a diagram. What kind of triangle am I drawing? A right triangle. And they're saying one leg is A and the other leg is A plus B. How do we identify the hypotenuse?
A squared plus B squared is equal to C squared.
No, in the diagram, how do we know which side's the hypotenuse? It's across from the right angle, right? So this is 15.
So could tell, right? Joey, you're so
Chills.
Happy birthday, Joey. So now we're going to make a new triangle. And what's happening in the new triangle? They're saying if the smaller leg is increased by 7, how am I going to represent that? A plus 7. The other leg remains the same.
How do you know A is the smaller piece?
Because
What if it's like -1?
you don't want to get into the idea of B being negative. It's better to assume that it's positive because then we could end up with a negative side length on the bottom, so we don't want that. So we'll just base it that we decided that A is smaller, and that's the easier one to decide, that we're adding A. B is not equal to 7, no. It's not isosceles.
It's not a no teacher.
All right, and so what's happening to the hypotenuse? It's increased by 5. So what does that make it? 20. All right. So obviously we need two equations. Does anybody know something we're allowed to use on right triangles, Damien? Exactly. We are going to use the Pythagorean theorem on each triangle. So we are going to have A squared plus the quantity of A plus B squared equals 15 squared. And the other one's going to be A plus 7 squared plus the quantity of A plus B squared equals 20 squared. Can I use elimination on this one?
Yes.
Yeah, why? Why am I able to use elimination? Anya?
Because A plus B squared is the same quantity in both.
Yeah, we have the quantity of A plus B squared in both of them, so I'm actually going to use elimination unless somebody feels strongly for substitution. We're going to have A squared plus the quantity of, actually, do this, A plus 7 squared plus the quantity of A plus B squared equals 400. And then we're going to have a squared plus the quantity of a plus b squared equals 225. I can't add these because nothing will cancel. So I can either subtract, or can I distribute in a negative and then add? Same thing as subtracting. So in the first column, I can't add those because they're not the same base. So I have to write them side by side. So we're going to say a plus 7 quantity squared minus a squared. And then the a plus b quantity squareds cancel. And then we're going to have that equaling to, what is it, 175? All right, I'll believe you. I believe you. So on the left side, I'm going to FOIL this out. If I FOIL this out, I'm going to get a squared plus 14a plus 49. And then we still have the minus a squared equals 175. This is so nice. Why is this so nice? Because the a squareds cancel. So much better than the other problems we did. If we solve this, we end up getting a is equal to 9. Now what do I have to do? Plug back in. So I'm actually going to choose the first triangle. A squared plus the quantity of a plus b squared equals 225. So we're going to have 81 plus 9, the quantity of 9 plus b squared equals 225. I'm going to subtract that 81. So 9 plus b quantity squared equals 144. Square root both sides. What do I get when I square root both sides? Good, plus minus 12. So then for b, I get negative 9 plus 12 or negative 9 minus 12.
Either equal to 3 or minus 3.
9. Can b equal negative 21?
No.
Good, why?
Because this is length, like something can't be like negative this.
Well, b never stood alone.
Like if when added up to a, it's like.
Good. So the length of a side was a plus b. Well, a is only 9, so 9 minus 21, isn't that a negative length? So once again, we're going to need to reject. So we're rejecting the negative 21, and b just equals 3. So we get a equals 9, and b is equal to 3. So one leg, sorry, the a leg is 9. What about the a plus b? That's going to be 12. We're done.
We finished.